Okay, so we're moving on with circles. You already know how to find circumference, diameter of a circle. You also know how to find the central angles and arc lengths and inscribed angles, inscribed quadrilaterals. So now we're going to talk about arc lengths today, which is different from arc measure. It says here previously we have found arc measures in circles, which measures the arc in degrees and is based on the measure of the central angle. Today we are going to find arc lengths. So arc lengths we are not going to measure in degrees. This is the same as if you took a portion of a circle and you stretched it out and you asked yourself, how long is this part of the circle? So if we're going to measure the length of the arc, we are going to have to find a fraction of the circumference, because remember, circumference is how long, how far we go if we go around the circle. So now what happens if we just take a portion of the circle? So if you remember when we learned about circumference, the formula for circumference was 2 pi r, right? But if you just want to find a portion of the circle, not the entire circle, you need to state what fraction of that circle you're going to talk about, which is going to be out of the total degrees in a circle, which is 360. So the formula for arc length is the arc measured in degrees out of 360 times the circumference, which is 2 pi r. You could also use pi times the diameter. So it says to find an arc length, we divide the measure of the corresponding central angle by 360, and then we multiply by 2 pi r. Recall that 2 pi r is the formula for circumference of the circle, so we're only finding a piece of the circumference. So let's take a look at some examples. For instance, this one says, find the length of arc EF. Notice how they're not saying find the measure, they're saying find the length. And that's our cue, so we know we need to find the arc length formula, the one we just saw up there. So it's going to be the portion of the circle. EF is just this part. So what is the degree measure of that portion of the circle? Should be 120 over 360 times 2 pi times the radius, which in this case is 6. So when you enter that on the calculator, you can simplify this fraction or not. I know that 120 divided by 360 is the same as 1/3. So I can rewrite that as 1/3 times 2 pi times 6, which gives me 12 pi over 3. I multiply the tops together, left the bottom alone, which is the same as 4 pi. You can leave your answer like this, or you can enter on the calculator and round to the nearest tenth or hundredth, whatever you're asked to do. And that is going to be in meters, because it's an arc length. Moving on to the next problem. Here they give you the diameter. They want you to find the length of arc CD. So arc CD is over here. So the portion of that circle is 60 degrees. So 60 out of 360, times 2 pi times the radius. Now here they give you the diameter. So I need to either find the radius, which is going to be half of the diameter, which is 12, or I could just do 24 times pi. 60 out of 360 is 1 over 6 times 2 pi times 12, which gives me, I'll multiply the tops together, 24 pi over 6, which is going to be, once again, 4 pi. And it's going to be centimeters. Now for the next one, they want you to find the measure of arc AB. Oh, they just want the measure of arc AB. They don't want the length. They just want the measure, no length. So the measure of arc AB should be the same as the central angle, which is 45 degrees. Now, if they ask for the length, that's a different formula. Then it will be the one we used. Now, for sector area, it's going to be similar to the length of a sector. However, we are going to do part of an area, which means it says here, we can find the area of a sector by finding a fraction of the area of the whole circle. So the beginning is going to look the same as the other one, the angle out of 360. But if you remember the formula to find area of a circle, it is pi r squared. So now we don't use 2 pi r because that is circumference. Now we are going to multiply by pi r squared. So it's the same type of work, but you need to know that when you look for the area of a sector, you use pi r squared. When you look for arc length, it's going to be 2 pi r. So to find a sector area, we divide the measure of the corresponding central angle by 360. Then you're going to multiply by pi r squared. Pi r squared is the formula for area of a circle. So we are really finding a piece of the area or a slice, okay? So over here, they want you to find the sector area below. So I am going to do the arc measure, which is 120. What portion of the circuit is? So 120 out of 360. But now I need to multiply that by pi r squared. So pi times 16 squared. And I know that 120 out of 360 is 1/3. 1/3. 16 squared is 256 pi. And I can just multiply the tops together. And I get 256 pi out of 3. And that gives me 16 squared to 56. Yeah, so this is going to be, I can simplify, but it's not really going to help much unless I give the answer as a decimal. So you can leave it like this, or you can enter your answer as a decimal. And that's going to be square meters or meters squared. Now, example 2, they say a circle has a radius of 12. Find the area of the circle whose central angle is 120. Same formula. So the arc measure is going to be 120. That's the fraction out of the whole circle times pi times the radius squared. So it's going to be 12 squared. This is 1/3. So 1/3 times 12 squared is 144 pi. And this one I can divide. I get 144 pi over 3, which is going to give me an answer of 48 pi. And it should be units squared, so square inches. And then we move on to the next problem. This one, they are asking you to find the area of sector XPY. This is just like a pizza slice, right? If you were going to divide this into parts, you'd have 8 slices, right? Because 45 times 80, times 8 would give you 360. You don't have to do what I'm doing. You could find the area of the whole circle and divide by 8. But if you just want to apply the formula that you just learned, you do 45 out of 360 times pi times the radius, which is 8 squared, which gives you, this is 1/8 times 64 pi, which is going to be 8 pi. And they don't give me units, so square units, because we're talking area. And here you have 1, 2, 3, 4, 5, 6 problems. Actually 7, 8. I am going to do, I think you can try on your own. You can try 1, 2, 3, 4, 5, 6. You can try on your own. The other ones I can show you later. Just don't do them for now. You're just going to be responsible for doing 1 through 6. This ones I can set it up for you. I'll show you how to set it up. So number 7 says, find the measure of a central angle of an arc if the radius is 18 and the arc length is 43.98 pi. So they gave you the arc length. So 43.98 pi is the arc length. That should be equal to the central angle, which we don't know, so we're going to call x out of 360 times 2 pi times the radius times 18. Okay, so then the pi's would cancel out, and you get 43.98 equals 36x over 360. And then you could simplify it to 43.98 is equal to, over 1, is equal to x over 10, which means when you cross multiply, it would be 439.8. So the radius is 18 and the arc length is oh, I know why. Because I radius is 18, so 36 over 10. Okay, these numbers are not making sense. Just leave it out. And then this one, they gave you the area. Oops, it would be the same idea, but don't worry about that. Just do 1 through 6, okay? Thank you so much.